Welcome everyone. In this video lecture, we will solve a GATE 2024 EC question in which we have to calculate the time constant in a inductor resistance based network, LR network we can say. So the question is in the circuit given below, the switch S was kept open for a sufficiently long time and it is closed at time t equals to 0. The time constant in second of the circuit for t greater than 0. Okay, when the switch is closed, then what should be the time constant? Okay, so this one is basically a problem consists of an inductor and resistor. So the time constant generally denoted by tau. Okay, so tau for a inductor and resistance based network will be L by R. Okay, so this should be our L by R. Okay, better to write L by R. This one is the formula. If time constant for the RC based network is simply RC. Okay, this formula we can also achieve by simple calculation. Okay, so this one for the okay. So in this question, this network consists of an inductor and a multiple resistor. So in this case, we can write the tau for the LR network will be L by R equivalent. Okay, so this can be easily achieved by using simple concept. So for this, I am just doing like this. Okay, some inductor is there, some resistor, and I am saying the current is flowing like I. Okay, and the voltage drop is our VL, and here we are, and the current is flowing in this loop is I. So one can write simply minus VL minus VR equals to 0 by applying KVL in this loop. So VR plus VL equals to 0. So VR is our IL plus VL is L times of di by dt. I am just going to prove this one means tau time constant will be L by R or not. How if someone don't know the formula, then they can easily derive by using this concept. Okay, so now one can also write this one di by dt plus R by L I equals to 0. So this one is nothing but simply a first order linear equation, just like dy by dx plus p of x, p as a function of x, y is to q of x. This one is a first order differential equation. Okay, I am highlighting this one. This one is our first order differential equation, and for this one what we have to do, we have to first find out the integrating factor, that is our e to the power px into dx, and the solution for this will be y equals to 1 by integrating factor, okay, into integration integrating factor into qx dx plus some constant. Okay, so this one is very important result. Okay, so I will use this concept, okay, to solving this equation. Okay, so directly one can write here the integrating factor if integrating factor e to the power p. So this one is r by l, okay, dt instead of here dx, it is dx, so we have to write dt. So integrating factor will be e to the power r by l into dt, so it should be t. Okay, simply dt integration e r to the power n dt. Now the solution will be y. So here no need to write y. So here what we can write, simple mathematics is there. Integrating factor I, the current value I equals to 1 by integrating factor 1 by e to the power r by l t, e to the power r by l t into integration, then what we have to do, integrating factor, so again e to the power r by l t into qx. So here this one is our qt, you can say this one is qt. So qt is 0 plus some constant value, say some constant, so this qt is 0. So one can easily write this as a 1 by e to the power r by l t. It should be 0, so it should be simply k. Okay, plus k. So the value will be k times of e to the power minus r by l of t. Okay, so one can also write, means the graph, means it will write down like this for t and I. Okay, this will go like this, I equals to k e to the power minus rl by t. Okay, so now here what we have observed, that this should be k e to the power minus t by tau. So this tau is nothing but simply L by R. So this one is the important result. That's why I have derived this one. Okay, I'm highlighting this. Why this one is important result? It is coming from this one, R by L tau. So this, so now if you have multiple resistance and inductor are there, so we have to find L by R equivalent. Okay, so now we have to go with the problem. Now theory part is over. So now this one is the circuit, we have to find the time constant. Okay, so for in such situation what we have to do, we have to eliminate the current source, and then we have to make this short. Okay, we have to make this short. Okay, so what we are doing, we have to make this. Okay, so now this one is our 4 ohm resistance. 4 ohm resistance is in parallel, so what we can write, this as a 3 Henry, and this 4 ohm for this one. Okay, I'm just doing like this. For this 4 ohm is in parallel with 4 ohm, so it should be 2 ohm. Okay, means R parallel with R, so it should be R square by 2R, or simply our R by 2. So this should be 4 by 2, so 2 ohm. So it should be our 2 ohm resistance, and then one more 2 ohm resistance is there. Okay, here, so we can make like this. Okay, or you can make here also, not an issue. So this should be 3 Henry by oh, 4 ohm. Okay, so the time constant will be L by R equivalent. So it should be 3 by 4. So 3 by 4 value will be 0.75 second. So this one is the correct answer. So we can easily find the value of time constant. Okay, so this one is the 3 by 4 value. So the main formula is this one. If we know the concept, we have to just open circuit the current source, close the circuit. Okay, switch should be closed, and then we have to find the R equivalent. So L by R equivalent. So it is coming 3 by 4, means it should be around 0.75. Okay, so the answer will be, I'm writing, okay, 0.75 in second. So it is already written, so I'm not writing in second. 0.75. So the thing is that this one is some concept. If you don't know the formula, you just write LR and just do like this, some mathematical calculation. This will give the time constant tau. So tau equals to L by R. So tau L by R equivalent. Then we have to deactivate, or this one we have to remove the this portion and we have to find like this. So this is all about the question based on the time constant calculation in an inductor resistance based network. So thank you for watching this video.